Welcome to the 60th lecture of digital electronics. So in lecture number 59 we have started with the decoders. We have done with what is a decoder. We have done with the 3-line to 8-line decoder and BCD to decimal decoder. So in this lecture we'll be dealing with first section will be 2-line to 4-line decoder, and second one is we will go with a realization of full adder using 3/8 decoder. Okay, so that will be built in this lecture. Only two topics in this lecture. So coming into 2-line to 4-line decoder. Okay, 2-line to 4-line decoder. Okay, so if you are drawing the block diagram of 2-line to 4-line decoder, that is 2/4 decoder, you are having two input lines, A and B, and there are four output lines, D0, D1, D2 and D3. There are four output lines. Now if you are drawing the truth table of this one, doing the truth table of 2-line to 4-line decoder, how many inputs are there? Inputs are only two inputs. So we are having A and B. A and B as inputs. And how many outputs are there? Outputs are D0, D1, D2 and D3. Okay. So just draw it here. Okay. Now we are having combination 0, 0, 0, 1, 1, 0 and 1, 1. So here we get 1, 1, 1 and 1. All other elements are 0. Okay. Now coming into expression of D0, D1, D2 and D3. So what is D0? D0 you will get it as A bar B bar. D0 is A bar B bar, or we can write it as A or B or bar according to De Morgan's law. So what is D1? D1 we can write it as A bar B. D2 we can write it as, what is D2? D2 we can write it as A B bar. A B bar. And D3 we can write it as what is D3? D3 is AB. Okay. So here you have A bar, B bar. So if I am drawing the circuit, here I am having A. Now next one is what I am having is A bar. Now B is there. Next one is what I am having is B bar. Okay. So this is A bar, B bar. Now I am having 4 AND gates. 1, 2, 3 and 4. So this is you are having D0, D1, D2 and D3. And what is D0? D0 is A bar B bar. And thus A bar B bar. What is D1? D1 is A bar B. A bar is here, B is here. So it is A bar B. What is D2? D2 is A B bar. D2 you will get it as A B bar. That is D2. What is D3? AB. D3 is you will get it as A and B. Okay. So this is basically a 2-line to 4-line decoder. Now let me realize this 2-line to 4-line decoder using NAND gates. 2-line to 4-line decoder. 2-line to 4-line decoder using NAND gates. Two-line to 4-line decoder using NAND gates. Okay. So here what I am choosing is I am having A and B. Okay, right? Okay. So here I have written D0 as A bar B bar, D1 as A bar B, and D2 is A B bar, and D3 is AB. So here we need to realize this same expression using NAND gates. So here I am introducing an enable bit. Here I am introducing an enable bit. Okay. So enable means if enable is high or low. If enable is high, you can it will trigger the circuit. It will trigger the circuit. Whereas if you are using NAND gate, if enable is low, then only output will be triggered. Then only output will be triggered. Now if I am drawing a two table of 2-line to 4-line decoder using this enable bit, I am having inputs. I am having only A and B. Okay. Inputs I am having A and B only. But along with that I am having an enable bit. Enable I am writing it as E. Now outputs I am having it as D0, D1, D2 and D3. So here I am writing 0 0, 0 0, 0 1, 1 0 and 1 1. Okay. Now here I am keeping enable as 0 for all these cases. Okay. Now if enable is 1 for any value of A and B, the value will be 1. That means here what I am going to do is if enable is 0 and if A and B is 0, you will get D0 as 0 and all other values are 1. Here enable is 0, here you will get D1 as 0 and all other values are 1. So it is basically the reverse logic of corresponding to AND gate. Here you will get A bar B. A bar B means you will get a D2. D2 is 0, all other elements are 1. Here D3 is 0 and all other elements are 1. Okay. And in this case, what happens is that when enable becomes 1, for any other value of, if enable becomes 1 for any other value of AB, they are making D2, D1, D2, D3 as 1 only. Okay. That means here I need to get the value as 0 as output. Okay. So that is the main crux of the lecture. Now that is the main crux of this point. Now I am having A is there. A bar is coming in. Now B is there. Next I have B bar. Now E bar. Okay. So I am having these three. Now how many NAND gates I require? I need only 4 outputs. So I need only 4 NAND gates. So it is 1, 2, 3, 4. I require only 4 NAND gates. Okay. Now what is the first one? First one is what I have is this one, D0. What is D0? D0 is A, B or E. Or you can write what you can say D0 according to 0 you can write as A or B or E. That means you can consider it as A bar, or you can write the expression of D0. D0 using NAND gate you can write it as A bar, B bar, E bar, the whole bar. Okay. So that is what? That is A or B or E. Okay. So here you can write A bar, B bar, E bar, the whole bar. What will you get? You will get it as D0. Now what is D1? D1 you can write it as A or it is A or B, it is A bar or B or E bar. Okay. Or if you are writing it in the other form, you will get A, B bar, E the whole bar. A B bar E the whole bar. We can write as here we get A B bar E. So that is D1. Coming into D2. So what is D2? D2 will get it as A bar B A bar B E. A bar A bar B E. So that is D2. Now what is D3? D3 is A bar B bar E. This A bar B bar E. Yeah. One second, D3 will get it as E bar D3. What should we get? D3 you should get it as A. Oh, one second, there is a mistake here. Okay, there is a mistake what I have made. Okay. In connecting this one. Okay, so here what we have is D3. Okay, now what is D0? D0 is you can consider A bar B bar E bar, right? Yeah. Okay, so it is A bar B bar E bar the whole bar. Okay, that is A bar B bar E bar the whole bar. Now what is D1? D1 is A bar B E bar. A bar B E bar. That's it. Okay, the whole bar. Now coming into D2. This D2. D2 is A B bar E bar. D2 is A B bar E bar. Yeah. This is A B bar E bar. A B bar E bar. That is D2. Now coming to D3. What is D3? A B E bar. You get A B. And the last one is E bar. Okay. So here what I am getting is D3 is you will get it as A B E bar the whole bar. What is it? That is A bar or B bar or E. Okay, so you are getting the expression like that. Okay, so so this is basically 2-line to 4-line decoder. Okay, so D0 you are getting it as A bar B bar E bar the whole bar. So that will get it as A or B or E. Again, what is D1? D1 is A bar or B or E the whole bar. A bar or B or E bar the whole bar. So yeah, so this is A B bar E the whole bar. Now coming into D2, what will we get? A B bar E bar the whole bar. Okay, and D3 is A B E bar the whole bar. So that is basically the 2-line to 4-line decoder using NAND gates only. Okay, so that is regarding 2-line to 4-line decoder. Now next comes realization of full adder using 3/8 decoder. Realization of full adder using 3/8 decoder. Okay. So let me first of all write the full adder truth table. Full adder truth table that I will write here. Okay. So you are having inputs are A B C. So 1 2 3 4 1 2 3 4 0 0 1 1 0 0 1 1 Cn, that is input carry. You can enter 0 1 0 1 0 1 0 1. So you have sum and carry. Okay. Now if you are writing the corresponding this one outputs here, you can write it as D0 D1. According to the 3/8 decoder, we can write the outputs as D0 D1 D2 D3 D4 D5 D6 and D7. Now coming into the sum and carry part. Okay. 0 plus 0 plus 0. Sum is 0, carry is 0. 0 plus 0 plus 1, sum is 1, carry is here 1 0. Here we get 1 plus 1. 1 plus 1 is sum is 0, carry is 1. Here again 1 0 1 0 1. Sum is 0, carry is 1 1 1 0. Sum is 0, carry is 1. Here sum is 1, carry is 1. Therefore we can write sum as. You can write the expression of sum. Sum is D1 or D2 or D4 or D7, right? Yeah, it is D1 or D2 or D4 or D7. D1 or D2 or D4 or D7. Now coming into expression of carry. Carry, you can write it as carry. You can write it as D3 or D5 or D6 or D7. D3 or D5 or D6 or D7. Okay. Where this D1, D2, D3, D4 and D7 etc. are the outputs of 3/8 decoder. Okay. Now I will draw the logic circuit. So I am drawing the logic circuit. Here I am having a 3/8 decoder. Okay. So I am having three inputs: A, B, C in. Okay. How many outputs? I am having D0, D1, D2, D3, D4, D5, D6 and D7. So what is sum? D1 or D2 or D4 or D7. Okay. If you are ordering these four elements, you will get the sum. So the 4 input OR gate, there you will get the sum. Now what is carry? D3, D5, D3 or D5 or D6 or D7. D7 is here. Okay. So if you are ORing these four, you will get the carry part. Okay. So this is how you are realizing a full adder using 3/8 decoder. Okay. So in the case of 3/8 decoder, the inputs are, if you are getting 0 0 0 0, then 0 0 0 as input, then the corresponding output D0 will be on. If it is 0 0 1, D1 will be on. 0 1 0, D2 will be on. Now if you are taking that into the expression of this sum, you will get sum as D1 or D2 or D4 or D7. Similarly carry, you will get it as D3 or D5 or D6 or D7. Okay. So this is the basic realization of full adder using 3/8 decoder. Okay. That means so the inference is that the decoders can be used to realize this full adder, half adder, or you can have full subtractor, half subtractor circuit. Okay. So I think you understood the concept of this 3/8 decoder and realization of full adder using 3/8 decoder. Now coming back into this lecture, in this lecture we have dealt with 2-line to 4-line decoder, and we have realized this 2-line to 4-line decoder using NAND gates, and then we have dealt an application of this 3/8 decoder. Here I have realized a full adder using 3/8 decoder. So thank you. hoping you to be in the next lecture also. Thank you.